All right, howdy folks. What I'm going to do in the next few videos is I'm going to go over some examples of related rates word problems. I hope that you have already watched the video, my previous video, where I go over a 7-step procedure. Doesn't have to be 7 steps. I use 7 steps, but 7-step procedure for solving a related rates problem. Now you can use this procedure for any related rates problem, but step 5 indicates we're only dealing in time as an independent variable. Very common to use time as the independent variable. And so all the problems that I'm going to do are going to involve change over time. And so basically there are about, I don't know, maybe 5 or 7 sort of standard problems. I'm only going to do 5 what I consider to be classic related rates problems in AP Calculus. And then almost every problem that I see in calculus, well in AP Calculus anyways, is just some sort of variation of one of these 7 problems. So we're going to start off with what I call the ladder problem. So here's the situation, and then I'll tell you why I call it the ladder problem, and why you can look at almost any problem that's like this and say, oh, that's basically the ladder problem, okay? But if you can do the ladder problem, then you can do any problem that is like the ladder problem. All right, here's the ladder problem. And the numbers vary. You know, you might see the exact same problem, only a ladder of a different length or something else. But we're just going to use this one. It says a 10-foot ladder leans against the side of a building. If the top of the ladder begins to slide down the wall, so if you have wall, ground, you got this ladder, right? If it starts to slide down the wall, it's going to do this, right? Until it hits the ground and it's flat. Okay, so that's basically what's happening here, and I've drawn a diagram of it right here. If the top of the ladder begins to slide down the wall at the rate of 2 feet per second, at what rate is the bottom of the ladder sliding away from the wall? See, when the top, here's our ladder, here's our wall, and here's the ground. Now we're going to presume, we usually presume that the wall meets the ground at a 90-degree angle. And sometimes that'll be stated in the problem, sometimes it won't be stated in the problem. It should be stated, but we're just going to assume it's a right angle. When the top of the ladder slides down the wall, the bottom of the ladder is going to slide away from the wall. And what this question is asking is, at what rate is the bottom of the ladder sliding away from the wall when the top of the ladder, that's the top of the ladder, is 8 feet off the ground, meaning the distance from the top of the ladder to the ground is 8 feet, okay? So here's what we're going to do. So here's our diagram, and I usually recommend that you draw some kind of diagram that can help you. You can look at it and understand. But the ladder problem is basically a right triangle problem where the hypotenuse is constant, okay? So the legs of the right triangle are changing, and the hypotenuse of the right triangle is not changing. It's constant. And anytime I see a problem that deals with both of the legs of the right triangle are changing, but the hypotenuse is constant, I call that the ladder problem. Okay? So here's what we're going to do. We're going to go through all the steps that I have. It says identify any given rates. All right? Well, what's given? We're told that the ladder slides down the wall at the rate of 2 feet per second. What that means is that this leg of the right triangle is getting shorter because the ladder is sliding down the wall. So we're going to name these sides. We need names for the sides of the triangle. The Pythagorean theorem typically calls them A, B, and C. So we're going to call this side A, we're going to call this side B, and we'll call the hypotenuse C. So what's happening here is leg A is getting shorter at the rate of 2 feet per second. And so the rate of change would be given as, we would call it dA dt. So we're going to say that step 1, we're going to say that dA dt the rate of change in leg A over time is 2 feet per second. But because it's getting shorter, we're going to say that it's -2, because when a length or when a volume or something, when a rate of change is indicating a decrease in the value, then that means that the rate of change is negative. So dA dt is -2. And that's the only rate of change that we're given in the problem. So now we're going to go to step 2, identify the unknown rate. Well, that's where it says at what rate. You're looking for a phrase that says how fast or at what rate. That's indicating your unknown rate. So at what rate is the bottom of the ladder sliding away from the wall? So the bottom of the ladder is sliding away from the wall, and so that means leg B is getting longer. And the rate at which leg B is changing, we can call that dB dt, okay? And we do not know that. We're trying to solve for dB dt. Step 3 says find a formula that relates the variables. Is there a formula that relates A and B? Well, there's a formula that relates A, B, and C, and it's the Pythagorean theorem. So step 3, we're going to use, since we're using distances of a right triangle, distances of a right triangle are related by the Pythagorean theorem. Well, that's one way to relate them. There are other formulas you can use. Some of them are based on the Pythagorean theorem, but let's just use the Pythagorean theorem. Step 4, plug in for constants. What that means is, are any of these variables not changing? Well, we know A is changing, and the question implies that B is changing, but C, the hypotenuse, is not changing. We're told that the ladder is 10 feet long, not changing. So we're going to plug 10 in for C. So our formula is now going to be A squared plus B squared equals 10 squared. And so we're going to actually resolve that. A squared plus B squared equals 10 squared is 100. So this is now the formula that we're going to work with. Step 5 says take the derivative with respect to time, d dt, every term. So we have A squared, we have B squared, and we have 100. We're going to do the derivative of those. So step 5 is the derivative of A squared is 2A dA dt. And you have to understand implicit differentiation to understand how to do the derivative of that. Hopefully you've already seen my video on implicit differentiation. Hopefully you've already gone through my basic video on related rates. And so now the derivative of B squared plus the derivative of B squared is 2B, okay? And then we're going to put on a dB dt. And lastly, the derivative of 100 is a constant, and the derivative of a constant is 0. So 0. So this is step 5. 2a dA dt plus 2b dB dt is equal to 0. It's getting easier and easier from this point on. Step 6, plug in all given and implied values. So look what we have. We actually have 1, 2, 3, 4 variables. We have A, we have dA dt, we have B, and we have dB dt. 2 of those were given to us in the problem. One of them we're solving for, dB dt, and then the fourth one is implied. Well, let's see how it's implied. First of all, we know dA dt is -2. So for step 6, we're going to plug in. We have 2. And by the way, you can cancel the 2 if you wanted to. If you want to divide by 2, divide by 2, divide by 2, you can cancel the 2. That's fine. I'm not going to do it because some people get confused when I do that, so I'm going to leave it in. But if you're an expert at algebra and you're fine with that, you can go ahead and cancel the 2 out. That's fine. So we're going to have 2, and then A. It says, the question says, at what rate is the bottom of the ladder sliding away from the wall when the top of the ladder is 8 feet off the ground? And that means that A in this problem is equal to 8. And then dA dt is given to us, that's -2. So we're going to put a -2 in for that, plus 2. Now what about this B here? B is the length of the distance from the wall to the bottom of the ladder when C is equal to 10 feet, when A is equal to 8 feet, Well, if we did the Pythagorean theorem, then that would make B 6 feet. In fact, this is a 3, 4, 5 triangle, okay? And you might have to use the Pythagorean theorem to find that. But basically, we're using the Pythagorean theorem to find the length of B when A has a length of 8. So we're going to put a 6 in here for B. And then we're solving for dB dt. And then this equals 0. So this is step 6. This is our formula. And then step 7 says solve for the unknown rate. So now all we have to do is a bunch of algebra to be able to solve for dB dt. So step 7, 2 times 8 times negative 2 is negative 32. Plus 2 times 6 is 12. Plus 12 dB dt is equal to 0. If I add 32 to both sides, I get 12 dB dt equals 32. And now I'm going to divide by 12 on both sides. Cancel. Divide by 12. And then the 32 over 12 can be reduced. Divide by 4 on the top and the bottom. And I get 8 over 3. So my answer, dB dt, the rate of change that we're asking for, is 8 over 3, and I need units. This question is giving us units in feet per second. So 8 over 3 feet per second. And that is the answer to this latter problem. Okay? So anytime that you have a question, a situation where the situation indicates a right triangle where the hypotenuse is not changing, but the legs of the right triangle are changing, you can use this procedure, you can use this example as a model for how to solve that problem.